Alright, in this video we are going to write the equation of a hyperbola that has a center at 6, -3. One focus is found at 6, 0, and one vertex is found at 6, -1. Alright, I'm going to put some grid lines on here. There we go. We're going to make a sketch. Now it's not going to be a perfect sketch or anything. This is mainly to give myself a visual because what I have to actually find here is the equation, but this is just going to help. Okay, so my lines are not going to be perfectly straight. I can't draw a straight line anyway. But, ooh, that one's really bad. Let me undo that one. Yeah. But we'll put on an X and Y axes here. Alright, and let's just plot these points first of all. Alright, so 6, -3, so 1, 2, 3, 4, 5, 6, down 1, 2, 3. Right here is my center. Okay? Now I have my focus, one focus at 6, 0, so right here, there's a focal point, and a vertex at 6, -1, which right there. Okay, now remember, you notice these line up vertically. I have center, vertex, focus. So that tells me this is going to open vertically, okay, because all of those are on the transverse axis. Now, to get the length of this transverse axis, the distance from the center to the vertex is going to be the value of A, okay? So, if I take 6, -1 and 6, -3. I mean, I could use the distance formula, but really all I have to do is count there are 2 units there. So A equals 2. Okay? And since all of those are vertical, as in all these points line up vertically, I know that the y squared, or y at least, is going to be here, and x is going to be here. Okay, but remember, my center is not at 0, 0. It's at 6, -3. So I am going to say y, now minus -3 gives you a +3. Okay, quantity squared. Okay, and then I have x minus 6 quantity squared. Okay, so I have the numerators now. Now if a is 2, a squared goes under here, so that means that this is going to be 4, because if a is 2, a squared's down here, so that'll be 4. Okay, so I need to find the values of C and B, and I already put my C on here. Now C, you know, is the distance from center to the focus. All right, now if my focus is at 6, 0, the distance from -3 to 0 is 3 units. So that means that C is 3. Okay, I can now use C squared equals A squared plus B squared to find B. Okay, well, if I subtract A squared from both sides, I have C squared minus A squared equals B squared. I like writing the B squared on the left, so I'm going to interchange. So B squared equals, and I am going to substitute. In place of C squared, I'm going to put 3 squared minus A is 2, so 2 squared. So b squared equals 3 squared is 9, 2 squared is 4, 9 minus 4 is 5. So b squared is 5. I do not have to find the value of b. I only need b squared. Okay? Now, here is 5. And then we say equals 1. This is my equation right here. Now, if I had to go on to draw the graph, let's just draw the graph because it will just help a little bit. All right? B would equal the square root of 5, which is, let's see, square root of 5 value. Let me get my calculator out. And 5 square root 2.2. Okay, approximately. So approximately 2.2 units. Okay, so we already moved up 2 for A, so we can move down 2 for the negative direction for A. There's my other vertex, okay? And then down 1 more to get the other focal point. All right, so we've got our distance for A. B is 2.2 units. So from here, I move out 2, and 0.2 is about there. So we're going to draw our little box, go out 1, 2.2, go up, there's our box. We can put on our asymptotes. Let me just change colors for the asymptotes. I like my asymptotes to have a different color. Okay, connect here. Get my asymptotes on here. Alrighty, and then let me change colors. My hyperbola, we already know it's vertical. So we ride along the asymptotes, touch the vertex, curve, and ride along the asymptotes. Now remember, this is not a perfect drawing by any means. Okay, but it just gives you a rough idea of what it looks like. Alrighty? Alrighty. Have an awesome time with these.